All right, so welcome back to your favorite Inorganic Tutor YouTube channel. Today is another episode. We want to look at how we can find the 30th and the 70th percentile, the difference, all right, given the probability density function, that is the PDF. All right, so, but before I begin, let me give a very big shout out to Mr. Rad and then Enoch, my own brother, and Issa Kunab, big ups. All right. Now, the problem is that an insurer's annual weather-related loss is a random variable with density function, that is the probability density function, right? Has been given us this, right? And we have to calculate the difference between the 30th and the 70th percentile, right? So now, how do we calculate the difference between the 30th and the 70th percentile given the probability density function, right? We know that the probability density function of x is given by from the range given, right? Looking at the range given, s is greater than or equal to 200. So from 200 to a variable x, right, of the function, right, of the function. But since we are using x here, let's change this variable to t. With respect to t, right? So here we are about to integrate this particular function. So after integrating this, then we take the 30th percentile and then the 70th percentile, then find the difference to know the percentile of this particular density function, right? So here we can change this particular function to 2.5 into 200 power 2.5 c power negative 3.5 dt, right? So having this, now let's integrate this particular function, right? So we know that when we integrate this, we are going to have 2.5 into 200 power 2.5 c power negative 2.5, right? All over negative 2.5 from 200 to x, right? Because when you add plus 1 to the negative 3.5, you get negative 2.5, right? So from here, we can say that this simplifies to minus 200 into 2.5 t power minus 2.5 x, right? So from here, when we uh, put in the limit, right? Put in the limit and simplify this integrand, then we equate first to the 30th percentile and then to the 70th percentile. After that, we find the difference, right? So let's go ahead. So when you simplify this very well, you're going to have 1 minus 200 into 2.5, 200 power 2.5 t power negative 2.5, right? Into t power negative 2.5, right? So this has been simplified. When we put in the limit, this is how it becomes, right? So since we have this now, we can now go ahead and put in the 30th percentile, right? So now At the 30th percentile, we have 0.30 is equal to 1 minus 200 power 2.5 t power negative 2.5, right? So when we simplify this very well, we know that this power t power negative 2.5 we can bring it down, right? To have 200 power 2.5 all over t power 2.5, right? Should be equal to should be equal to um should be equal to 0.7, right? Because when we bring this here and we send the 0.3 to this side, it's going to be 1 minus 0.3, and that is 0.7, right? So now we can say that 200 power 2.5 should be equal to 0.7 times t power 2.5, right? So when you have this, now we can divide both sides by what? 0.7. So we have 200 power 2.5 all over 0.7 should be equal to t power 2.5, right? So from here, we know that t power 2.5 should be equal to, when you simplify this very well, you have 808122.0356, right? So now we take power 2.5 on both sides. So we have t is equal to 808122.0356 power 2.5, right? So right? So from here, right? So from here, we have t be equal to 230.66982, right? So we know that at the 30th percentile, this is the probability density function, right? So at the 70th percentile also, at the 70th percentile, we have the 70th percentile is going to be 0.7, right? So 0.7 should be equal to the integrated function, right? Which is 1 minus 200 power 2.5 t power negative 2.5, right? So from here, we bring this here and we send this here, right? So we have 200 power 2.5 t power negative 2.5 should be equal to 0.3, right? Because we send this here, we have 1 minus 0.7. And that gives us, this simplifies to 200 power 2.5 all over t power 2.5 should be equal to 0.3. So now when we cross multiply, then we have 0.30 t power 2.5 should be equal to 200 power 2.5, right? So here again, we divide through by 0.3 and now we have 2.5. T power 2.5 should be equal to 200 power 2.5 all over 0.3. Right. So now again, we take 2.5 roots of this particular number, right? 2.5 root of this particular number, and that is 200 power 2.5 all over 0.3, right? So we have t should be equal to 323.729 7289, right? So this is the percentile, the 70th percentile, and this is the 30th percentile, right? And we were asked to find the difference between the 30th and the 70th percentile. So now the difference between the 30th and 70th percentile is 323.7289 minus 230.668982, and that gives us 93.03, right? 93.03. So this becomes the difference between the 30th and the 70th percentile given the function, right? The PDF function, right? So the idea is that whenever we are given the probability density function to find the difference between the 30th and the 70th percentile, whatever percentile we are asked to find the difference, we have to integrate that particular function. Then after, we equate it to the first percentile, which is maybe the 30th percentile, find the value, and then equate it to the second percentile, which is the 70th percentile, find the value. After that, you find the difference. The idea is that make sure the difference remains positive, right? So in this case, the difference over here is 93.03. Right, so it means that the insurance annual weather related loss is a random with a random variable, which is the density function. The difference between the 30th and the 70th percentile is 93.03 respectively. Thank you very much for watching this video. Watch out for more content on probability or exam P questions. Thank you. Bye.